The ecliptic is the apparent path of the Sun on the celestial sphere, and is the basis for the ecliptic coordinate system. It also refers to the plane of this path, which is coplanar with the orbit of Earth around the Sun. The path of the Sun is not normally noticeable from Earth's surface because Earth rotates, carrying the observer through the cycles of sunrise and sunset, obscuring the apparent motion of the Sun with respect to the stars. Sun's apparent motion. The motions as described above are simplifications. Due to the movement of Earth around the Earth-Moon center of mass, the apparent path of the Sun wobbles slightly, with a period of about 1 month. Due to further perturbations by the other planets of the Solar System, the Earth-Moon barycenter wobbles slightly around a mean position in a complex fashion. The ecliptic is actually the apparent path of the Sun throughout the course of a year. Because Earth takes 1 year to orbit the Sun, the apparent position of the Sun also takes the same length of time to make a complete circuit of the ecliptic. With slightly more than 365 days in 1 year, the Sun moves a little less than 1 degree eastward every day. This small difference in the Sun's position against the stars causes any particular spot on Earth's surface to catch up with the Sun about 4 minutes later each day than it would if Earth would not orbit. A day on Earth is therefore 24 hours long rather than the approximately 23-hour, 56-minute sidereal day. Again, this is a simplification, based on a hypothetical Earth that orbits at uniform speed around the Sun. The actual speed with which Earth orbits the Sun varies slightly during the year, so the speed with which the Sun seems to move along the ecliptic also varies. For example, the Sun is north of the celestial equator for about 185 days of each year, and south of it for about 180 days. The variation of orbital speed accounts for part of the equation of time relationship to the celestial equator. Because Earth's rotational axis is not perpendicular to its orbital plane, Earth's equatorial plane is not coplanar with the ecliptic plane, but is inclined to it by an angle of about 23.4 degrees, which is known as the obliquity of the ecliptic. If the equator is projected outward to the celestial sphere, forming the celestial equator, it crosses the ecliptic at 2 points known as the equinoxes. The Sun, in its apparent motion along the ecliptic, crosses the celestial equator at these points, one from south to north, the other from north to south. The crossing from south to north is known as the vernal equinox, also known as the first point of Aries and the ascending node of the ecliptic on the celestial equator. The crossing from north to south is the autumnal equinox at ascending node. The orientation of Earth's axis and equator are not fixed in space but rotate about the poles of the ecliptic with a period of about 26,000 years, a process known as lunisolar precession, as it is due mostly to the gravitational effect of the Moon and Sun on Earth's equatorial bulge. Likewise, the ecliptic itself is not fixed. The gravitational perturbations of the other bodies of the Solar System cause a much smaller motion of the plane of Earth's orbit, and hence of the ecliptic, known as planetary precession. The combined action of these two motions is called general precession, and changes the position of the equinoxes by about 50 arcseconds per year. Once again, this is a simplification. Periodic motions of the Moon and apparent periodic motions of the Sun cause short-term small-amplitude periodic oscillations of Earth's axis, and hence the celestial equator, known as nutation. This adds a periodic component to the position of the equinoxes. The positions of the celestial equator and equinox with fully updated precession and nutation are called the true equator and equinox. The positions without nutation of the mean equator and equinox. Obliquity of the ecliptic. Obliquity of the ecliptic is the term used by astronomers for the inclination of Earth's equator with respect to the ecliptic. or of Earth's rotation axis to a perpendicular to the ecliptic. It is about 23.4 degrees and is currently decreasing 0.013 degrees per 100 years due to planetary perturbations. The angular value of the obliquity is found by observation of the motions of Earth and other planets over many years. Astronomers produce new fundamental ephemerides as the accuracy of observation improves and as the understanding of the dynamics increases, and from these ephemerides various astronomical values, including the obliquity, are derived. Until 1983 the obliquity for any date was calculated from work of Newcomb, who analyzed positions of the planets until about 1895. Epsilon equals 23 degrees 2708, 26 minus 46. 845 T minus 0. 00592 plus 0, where epsilon is the obliquity and T is tropical centuries from B 1900.0 to the date in question. From 1984, the Jet Propulsion Laboratories to series of computer-generated ephemerides took over as the fundamental ephemeris of the astronomical almanac. Obliquity based on DE 200, which analyzed observations from 1911 to 1979, was calculated. Epsilon equals 23 degrees 26 minutes 21 seconds. 45 minus 46. 815 T minus 0. 0062 plus 0, where hereafter T is Julian centuries from J 2000.0. JPL's fundamental ephemerides have been continually updated. The Astronomical Almanac for 2010 specifies epsilon equals 23 degrees 26 minutes 21 seconds. 406 minus 46. 836,769 T minus 0. 001831 T2 plus 0. 00200340 T3 minus 0. 576 times 10 minus 6 D4 minus 4. These expressions for the obliquity are intended for high precision over a relatively short time span, perhaps plus or minus several centuries. J. Lasker computed an expression to order T10 good to 0. 04, 1000 years over 10,000 years. All of these expressions are for the mean obliquity, that is, without the nutation of the equator included. The true or instantaneous obliquity includes the nutation plane of the Solar System. Most of the major bodies of the Solar System orbit the Sun in nearly the same plane. This is likely due to the way in which the Solar System formed from a protoplanetary disk. Probably the closest current representation of the disk is known as the invariable plane of the Solar System, Earth's orbit, and hence, the ecliptic is inclined a little more than 1 degree to the invariable plane, and the other major planets are also within about 6 degrees of it. Because of this, most solar system bodies appear very close to the ecliptic in the sky. The ecliptic is well defined by the motion of the Sun. The invariable plane is defined by the angular momentum of the entire solar system, essentially the summation of all of the orbital motions and rotations of all the bodies of the system, a somewhat uncertain value that requires precise knowledge of every object in the system. For these reasons, the ecliptic is used as the reference plane of the solar system out of convenience. Celestial reference plane. The ecliptic forms one of the two fundamental planes used as reference for positions on the celestial sphere, the other being the celestial equator. Perpendicular to the ecliptic are the ecliptic poles, the north ecliptic pole being the pole north of the equator. Of the two fundamental planes, the ecliptic is closer to on moving against the background stars. Its motion due to planetary complete precession being roughly 1/100th of the celestial equator. Spherical coordinates, known as ecliptic longitude and latitude, celestial longitude and latitude, are used to specify positions of bodies on the celestial sphere with respect to the ecliptic. Longitude is measured positively eastward 0 degrees to 360 degrees along the ecliptic from the vernal equinox, the same direction in which the Sun appears to move. Latitude is measured perpendicular to the ecliptic to plus 90 degrees northward or minus 90 degrees southward to the poles of the ecliptic, the ecliptic itself being 0 degrees latitude. For a complete spherical position, a distance parameter is also necessary. Different distance units are used for different objects. Within the Solar System, astronomical units are used, and for objects near Earth, Earth radii kilometers are used. A corresponding right-handed rectangular coordinate system is also used occasionally. The x-axis is directed toward the vernal equinox, the y-axis 90 degrees to the east, and the z-axis toward the north ecliptic pole. The astronomical unit is the unit of measure. Symbols for ecliptic coordinates are somewhat standardized. See the table. Ecliptic coordinates are convenient for specifying positions of solar system objects, as most of the planets' orbits have small inclinations to the ecliptic, and therefore always appear relatively close to it on the sky. Because Earth's orbit, and hence the ecliptic, moves very little, it is a relatively fixed reference with respect to the stars. Because of the precessional motion of the equinox, the ecliptic coordinates of objects on the celestial sphere are continuously changing. Specifying a position in ecliptic coordinates requires specifying a particular equinox, that is, the equinox of a particular date, known as an epoch. The coordinates are referred to the direction of the equinox at the date. For instance, the astronomical almanac lists the heliocentric position of Mars at 0h terrestrial time, the 4th of January 2010, as longitude 118 degrees 09:15, 8 latitude plus 1 degree 43 minutes 16 seconds. 7. True heliocentric distance 1.63024454 astronomical units, mean equinox and ecliptic of date. This specifies the mean equinox of the 4th of January 2010 0h as above, without the addition of nutation. Eclipses, because the orbit of the Moon is inclined only about 5.145 degrees to the ecliptic and the Sun is always very near the ecliptic. Eclipses always occur on or near it. Because of the inclination of the Moon's orbit, eclipses do not occur at every conjunction and opposition of the Sun and Moon, but only when the Moon is near an ascending or descending node at the same time it is at conjunction or opposition. The ecliptic is so named because the ancients noted that eclipses only occurred when the Moon crossed it. Equinoxes and solstices. The exact instance of equinoxes are solstices of the times when the apparent ecliptic longitude of the Sun is 0 degrees, 90 degrees, 180 degrees, or 270 degrees. Because of perturbations of Earth's orbit and peculiarities of the calendar, the dates of these are not fixed. In the constellations, the ecliptic currently passes through the following constellations. Astrology. The ecliptic forms the center of a band about 20 degrees wide called the zodiac, on which the Sun, Moon, and planets are seen always to move. Traditionally, this region is divided into 12 signs of 30 degrees longitude, each of which approximates the Sun's motion through 1 month. In ancient times the signs corresponded roughly to 12 of the constellations that straddle the ecliptic. These signs give us some of the terminology used today. The first point of Aries was named when the vernal equinox was actually in the constellation Aries. It has since moved into Pisces.